Good morning everyone. I am Renu Sharma, Assistant Professor EC Department from the college, that is Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to start with the new next topic of the subject, that is Data Communication Networks KEC 063, and the topic of today's lecture is Ethernet. So, these are the contents of my lecture, that is types of Ethernet we will discuss and changes in the standard. So, in the last lecture we have discussed about different types of Ethernet. Ethernet is basically related to the LAN, that is local area network, and there are different depending on the number of users it can accommodate or it can allow, and the bandwidth it can allow. So, on that purpose different types of Ethernet are dependent. So, we will discuss different types of Ethernet in this lecture. So, this is the standard Ethernet common implementation. It is divided into different types of categories, like 10 base 5 it has used, then 10 base 2, 10 base T and 10 base F. So, this is basically the first type of the Ethernet, that is the standard Ethernet, and it is going to use the frequency or the range, that is 10 megabits per second, and its base then 5. So, I am going to tell you each value is having their own meaning. Then this first one is based on this bus technology, that is the bus topology, you can say. It is a kind of network topology where there is a single backbone is there between the transmitter and receiver, and a primary component or the primary device will going to transfer the information to more than one secondary devices. So, this is how the information will be transmitted. Now, this is based on the thick coaxial cable. What is coaxial cable? Coaxial cable is nothing, it is a kind of wired communication medium through which the information will be transmitted. It is based on the coaxial cable. Now, next one is 10 base 2. This is also based on bus topology, and it is based on the thin coaxial cable. So, after the twisted pair cable, because initially twisted pair cables are used, which is used for the transmission of voice channels, voice signals, these are used for transmission, and secondly they are only feasible for short distance communication, and that is why coaxial cable comes into the picture, where it can be used over a longer distance, it can accommodate larger number of users. So, this is how this coaxial cable are used. Now, next one is 10 base T. Now, what is 10 base T? It is based on the star topology, first thing, and second thing it is UTP based. So, UTP is also a kind of twisted pair cable technique. Now, last one is 10 base F. F is based on the optical fiber cable, and it is based on the star topology. Now, you can see from this segregation that first two are based on this bus topology and the next two are based on the star topology, and these are based on coaxial cable and these are based on the UTP and fiber respectively. Now, this is the encoding in Ethernet that we have to see how the encoding has to be done in case of Ethernet. When we are considering the transmission through a LAN through Ethernet, which is a local area network, the transmission in that condition is basically in a very short distance, means it is installed in a office, it is installed in a small unit. So, in that case this LAN comes into the picture. Now, it can be used to transmit the 10 Mbps of data, that is 10 megabits per second of data it is used to transmit, and it is using this Manchester encoding. Now, Manchester encoding is nothing, it is a kind of encoding technique where it can be used for the detection and removing of the error, it can be used for that purpose. So, that is the Manchester encoding. Now, this is the station. Now, this data has to be transmitted through this twisted pair cable or optical fiber cable. So, any type of wired communication you can consider, either you can consider this optical fiber cable or twisted pair cable, but depending on the distance it can cover. Secondly, for what purpose you are establishing this network, like if you want to transmit only the voice channels and this requires a very short range of frequency, then in that condition this twisted pair cable can be used. But if you want to transmit the data for internet connectivity, high speed data you require, and more number of users are going to use a common channel, then in that condition this optical fiber cable are used as a channel. So, these both are basically wired connection. Now, from this channel it has been delivered to this Manchester decoder, and then 10 Mbps of data it will going to deliver at the receiver side. So, this is nothing, it is the transmitter side and this is the receiver side, but the main thing that you have to consider that in case of the standard Ethernet, it will be used for the transmission of 10 Mbps of data, that is 10 megabits per second. Now, next is 10 base 5 implementation. As I have told you in the flow chart that we have seen where the different segregations are there, what is 10 base 5? 10 base 5 is nothing, 10 means it is used to transmit the data up to 10 megabits per second, base means it is used for the baseband or the baseband transmission or digital transmission. What is baseband? There are basically two types of transmissions are there. First one is the baseband and second one is the passband. Now, what is baseband and what is passband? In case of this baseband technology, baseband technique, if you are considering for the purpose of transmission, then in that condition no modulation or demodulation is used and the data is transmitted in the raw form. There is no such changes are there in case of the signal. So, that is the case for baseband transmission. So, no changes has to be made in case of this baseband data transmission and reception. Now, next one is, and this is also used for baseband is used for short distance communication, it is not used for the long distance communication. Now, in case of this passband technology, passband is used for long distance communication, and secondly if you want to transmit the data over a longer distance, then a kind of modulation and demodulation is required. Now, what is modulation? Modulation is nothing, it is a kind of technique where the data has to be superimposed, the original data is superimposed on a high speed or high frequency carrier signal, so that it can travel over a longer distance. So, that is the case for passband transmission. Now, here this is based on, and lastly what is 5 means maximum length of the wire that has been connected between the transmitter and receiver is 500 meter. Now, this is based on the bus topology, as you can see this is the cable end 1, this is the cable end 2nd. Now, these are the different systems that are connected to this backbone, this is nothing, it is the backbone, the main unit or the main connection between the cable ends. If there is any problem occur in this backbone, then this whole network will going to suffer. So, there will be no proper transmission of information will take place. Now, this is the cable end at this side and this side, these are the computers that are connected through this backbone. These are nothing, these are the tap lines through which these devices are connected, and this is the basic structure of 10 base 5 diagram. Now, these are the transceivers. Transceivers means it is a combination of transmitter and receiver, means you can initiate the transmission through this device or and you can receive the information through this device. So, maximum is 50 meters thick coaxial cable, maximum length is basically 500 meter, that can be done with this 10 base 5. Now, next is 10 base 2. This is same as that 10 base 5, but the basic difference is that it is the maximum length that it can cover is 185 meter through this optical coaxial cable. So, this is the cable end, this is again the cable end, these are the devices that are connected, the computers are connected through these devices, these are nothing, these are the connectors that are used to connect the T point connectors are there, and then this is thick coaxial cable. Its maximum length is shown as 185 meters. So, this is the 10 base 5 implementation which has been shown in this diagram. Now, next is summary of the implementations. Implementation, there are 4 types of implementations which are feasible with this standard Ethernet, that is first one is 10 base 5, 10 base 2, 10 base T and 10 base F. So, this is using the media, this is using the thick coaxial cable, this is using thin coaxial cable, then 2 UTP it is using, and then it is using the 2 optical fiber cables are used for this 10 base F. Now, maximum length for this condition is 500 meters, for this case is 185 meter, then maximum length is 100 meter, and for this it is 2000 meters. So, this is the case for maximum length that has been feasible with this condition. Now, next is the line encoding. Line encoding, this is the Manchester encoding. So, in all the cases, if you can see that we have used the system has used this Manchester encoding. So, this is basically a very you can say very feasible, very accurate kind of encoding that has been used in all the 4 cases. So, this is the summary of all the implementations that are possible with this standard Ethernet connection. Okay, so, this is the table showing the different implementations. Now, next we will move to changes in the standard. So, as we have seen the standard Ethernet is basically it is been using the transmission rate, that is 10 megabits per second, but if with the increasing demand of the internet, with the increasing number of users, the demand of internet has increased. So, we have to just move to different range of frequency, means larger data has to be delivered at the receiver side. So, for that condition, for to justify that condition, there are different variations of the standards are available, different variations are available. So, it has gone through several changes before moving to the higher data rates. These changes actually opened the road to the evolution of the Ethernet to become compatible with the other high data rate LANs. So, as I have said that with the increasing demand of the internet, with the increasing demand of the number of users, the data rate has to be increased, and this leads to changes in the standard Ethernet. A network with and without a bridge. So, this diagram is basically showing that how if the number of users in a LAN, this is nothing, it is the LAN which is connected in a bus topology condition. This is bus topology, this is again the bus topology. So, these both are the examples of Ethernet, both are connected in bus topology. This is the backbone, if you can see. Now, you can see that 6 computers are connected this side and 6 computers are connected this side, which means large number of users are going to use a common channel. In that case, if this system is using, if connected without a bridge, and in this system it is connected through a bridge. So, what is the difference between both the diagrams? If you can see that whenever there is a connection is established in a network through a wired channel, wire has been established between the transmitter and receiver. So, there is an intermediate device is required, so that the transmission and the reception between the set of devices that are connected at both the ends will be more accurate. As you can see, if 6 devices are connected to the this transmitter side and this is connected at the receiver side, and the length of this wire is not that short which is shown in this diagram, it is quite in meters or in kilometers. So, if there is an intermediate bridge is there, so the transmission or the reception in this condition is quite better as compared to the first condition, because there is an intermediate node is there which will going to just remove the noise, which is going to amplify the signal. And any device you can use, either you can use a router, you can use a gateway, you can use a switch, depending on the application you can use any of the connecting devices in a network. So, this will basically used to smoothen the transmission and reception at the transmission and the transmitter and the receiver side. So, this is the work of this connecting device. Now, next we are moving towards the switched Ethernet. What is a switched Ethernet? So, switched Ethernet is nothing, it is a replacement of the bridge. I have told you that there are different types of devices are there, like you can connect through a bridge, you can connect through a switch, you can connect through a hub, router, or you can also use a gateway. So, any of the device, these are basically related to a network, these are the connecting devices. Depending on the application, you can use any of the device for connecting one or more network. Now, you can see this is the different example, which is a switched Ethernet. This is just a Ethernet where single computers are connected in their domains through this switch. So, whatever information you want to transmit, let us say this is the transmitter side, this is transmitter 1 and this wants to transmit the information to this receiver. It has to be done through the switch. So, there is an intermediate device which has been connected between the transmitter and receiver. You cannot directly transfer the information from one transmitter to the other receiver. So, this is the case for the switched Ethernet. So, basically what it will going to do, the disadvantage of using this switch is there is no security is there, the data is not secured because it can be heard by the third party also. Let us say somehow through this switch, the switching operation from this device to this device is not smoothen, means it is not well behaved or well done. Then in that condition, maybe the case is there that this device will going to hear that what is been transmitted from this transmitter 1 to this receiver 1. So, in that case this will act as a third party and that will going to listen whatever transmitted in the first case. So, this will leads to security issue. So, that is the disadvantage of using an intermediate device, maybe it is a switch, but the basic advantage is that that whenever it is going to be used between the transmitter and receiver, then what it happens that it will going to deliver with a very amplified version of that, removing of the noise is also performed in that intermediate device. So, this is the case for switched Ethernet. Now, next is the full duplex switched Ethernet. Now, there are three different types of duplexing operations are there. First one is the simplex method, that is nothing, it is unidirectional situation. Second type is half duplex, and third one most important is the full duplex. What is the difference between these three cases? In case of simplex, whenever a simplex channel is set up between the transmitter and receiver, then it is unidirectional, it is from the transmitter to the receiver only. The receiver cannot transmit the data to the transmitter back. So, this is the unidirectional case. In case of this half duplex, the data will be transmitted between the transmitter and receiver, but in the both directions, but not at the same point of time. It has to wait. Like the best example of this half duplex condition is the walkie talkie. If you know that whenever both the transmitters or both the transmitter and receiver will going to talk at the same point of time, then there is clashing of information will be there and that information will not be delivered at accurately. So, that is the drawback of using this half duplex. In this condition the data will be transmitted only at a not at the same point of time. But in case of this full duplex, what it is shown over here, that it is first thing it can transmit and receive. So, it will act as a transmitter and receiver. Secondly, it can be done at the same point of time, means parallelly you can transmit and the same device can be used to receive the data. So, in mobile communication if we talk about, or in network, if any device which will accomplish this kind of setup of full duplex, so that will be more beneficial because at the same point of time it can transmit and receive the data. What is the benefit? Benefit is that it is time saving. So, this is the setup that has been using this full duplex switched Ethernet. A switched intermediate node has been used, and these all the devices are connected in will transmit the data in both the directions. So, it can transmit and receive at the same point of time. So, this is the full duplex condition. Now, next we will move to what is fast Ethernet. After this standard Ethernet, there is a fast Ethernet. It was designed to compete with LAN protocols such as FDDI or fiber channel. Then IEEE created fast Ethernet under the name, that is 802.3u. So, it can also be written as IEEE 802.3u. So, this is a standard that has been established for this fast Ethernet. Now, next is fast Ethernet is backward compatible with the standard Ethernet, but it can transmit the data 10 times faster at the rate of 100 Mbps. So, standard Ethernet will basically going to transmit the data at 10 Mbps of speed, but in case of this fast Ethernet, it will going to transmit the data 10 times the standard Ethernet data. So, it becomes 100 Mbps of data. So, this is a variation or the change in standard that has been done with the use of this fast Ethernet. So, in this condition it will going to transmit at a higher speed, means larger data can be transferred in this condition, that is known as the fast Ethernet. So, that is why it's the name is written that it can be used to transmit the data at a higher rate, 10 times greater than the standard Ethernet. Now, next is fast Ethernet implementation. So, these are the different implementations are there, like this is 100 Mbps of data it can be used for transmission. Then this is also using this baseband technology, means modulation and demodulation is not required in this case. This is based on the 2 wire category, that is 5 UTP. Now, next type of fast Ethernet implementation is 2 wire optical fiber cable it is used, that is denoted by this one, fiber optic cable, and in this case this is using this 4 wire category 3 UTP. So, this means this is using the UTP wire. So, T means it is using the UTP wire, and this is using 5 UTP and this is using the 3 UTP condition. Now, the summary of the fast Ethernet case is that there are 3 types of implementations that are possible with this fast Ethernet. As you can see, this is 100 base TX, this is 100 base FX, then this is 100 base T4. Then media that is using is STP or UTP, it is using fiber optic cable, it is again using the category 4 UTP. Number of wires is required is 2, it is requiring 2, and 100 base T4 requiring 4 wires. Maximum length is, for all the 3 cases, the maximum length it can be used to transmit is 100 meter, means 100 meter of wire can be connected between the transmitter and receiver. This is the maximum length, maybe you can use less than that. Then block coding which is using is 4B by 5B, this is also using, and this is not using any kind of block coding. Now, line coding it is using this Manchester coding, this is NRZ and this is using 8B by 60. So, this is the summary of the fast Ethernet condition. Now, next is the Gigabit Ethernet. Now, after this 10 Mbps, then we have moved to 100 Mbps, then we have moved to 1000 Mbps of data. So, this is nothing, this is the 1000 Mbps you can say, or 1 gigabit per second you can say. So, there are 4 different implementations of this Gigabit Ethernet connection. This is 1000 base SX, that is 2 wire shortwave optical fiber cable it has used. In this case, this is 1000 base LX, which means 2 wire long wave optical fiber cable. Then this is 2 wire copper STP it has used. Then 1000 base T, that is 4 wire UTP it has been using. So, this is the implementation of gigabit. So, in this condition, in this case basically it is using the 1 gigabit per second connectivity. This is encoding in Gigabit Ethernet implementation. You can see over here that there are 3 different options are available at the transmitter side. This is the first case, this is the second case which is using this 1000 base T. You can see that this is using the block encoder at the transmitter side, and block encoder same has been used at the receiver side, and 2 fiber or 2 STPs are used at the station. Now, same the implementation is there with this, but it is using a different type of encoder, that is 4D PAM5 encoder. This is also using the 4D PAM5 decoder, and it is using the 4 UTP cable. So, this is the encoding in Gigabit Ethernet implementation. So, these are the references that you can go through. So, in this lecture we have discussed about different types of implementations of Ethernet, standard Ethernet, then we have seen fast Ethernet and Gigabit Ethernet. So, this is all about this lecture. So, thank you.